this is the last session, so I'll try to be as efficient. The start was not very efficient, but I'll try to be as efficient as possible with the time. Talking about efficiency, so the topic of today's talk is essentially building an efficient observability strategy for AWS environments. My name is Chinmay Gaikwad. I'm a technical evangelist here at Epsagon. So a bit about myself. I started off as a software engineer and then continued my journey through various roles, including technical marketing at big companies such as Intel and IBM, as well as small startups. The picture on the right is me in Vietnam, in this town called Sapa. If you haven't been to Sapa or Vietnam, I'd highly recommend it. It's a beautiful place. Okay, so let's get on with the talk. In this session, we'll cover how we have seen the evolution of microservices. And then because of this, why do we need an efficient observability strategy? And then we'll see how to build one. So let's get on with the talk as soon as possible. So as you might have known, over the last decade or so, we have seen a huge shift in the architecture, right from being a monolithic based architecture to a microservices based architecture. So you can imagine a monolithic application broken down into smaller mini apps, and they essentially have been used to scale better or to develop better. We at Epsagon have seen our customers use microservices to their maximum advantage. And the benefits of microservices are not restricted to any specific company or any specific industry. It is across all over the board. So companies such as Adobe or even Vonage have used microservices to go to market faster or develop feature faster and increase their revenue. But as Werner Vogels once said, everything fails all the time, and I kind of agree with it. So what if something fails in a microservices environment? That's when the problem comes in. It becomes really complicated to troubleshoot applications because microservices is such a complicated environment. To dive a bit deeper into this, let's see why it becomes difficult. We know that today microservices are kind of hosted in the cloud. So we have the cloud APIs such as Amazon APIs or Azure APIs. But on top of that, we also have third-party APIs such as Stripe or Auth0. And these both intermingle with each other. So that definitely adds to the complexity. On top of that, we have containers and serverless environments whose behavior is not predictable. Again, that adds to the complexity. And finally, the logic of the code was within an application before, but now is between microservices because of this change. So if you consider a business use case, as you can see, almost 3/4 of the errors are found by customers before an operations team can find it. Also, every minute of downtime costs companies around $8,000. These are huge numbers. So how do you reduce these numbers? That's where observability comes in. So before we deep dive into observability, let's look at what observability exactly means. Observability can be thought of as 3 pillars: metrics, logs, and traces. Metrics tell us what exactly is happening in an environment. It can be application level metrics or even infrastructure metrics. Logs tell us why something is happening, whereas traces tell us where exactly it is happening. So why do we need a new observability outlook? It is effectively because traditional APMs were built to see within microservices and not between microservices. They were built for monolithic architecture and not microservices architecture. On top of that, traditional APMs generally use heavy and manually instrumented agents. So these agents necessarily don't work in a cloud environment. On top of that, traditional APMs were focused on infrastructure monitoring, but application monitoring has gained a lot of importance over the last 5-6 years. And finally, even if you have log aggregators, logs don't really work as a starting point in troubleshooting microservices world. Why? We'll see that with an example. Let's consider an example of a simple virtual shop. Here you have the HTTP server which authenticates requests using Auth0 and then pushes them onto a Kafka stream. A Java application posts the stream and then updates the DynamoDB table. Let's say you face a problem where users complain about orders that were sent but not handled. Where would you start? Essentially, you would start by looking at dashboards. So if you look at Kafka metrics, for example, you see different graphs and you see there are no spikes here, no anomalies here. So everything looks fine. So we need to look at some other microservices graphs. Then you move to DynamoDB metrics. And here you can see spikes. Now these are interesting spikes. That's because these are the count of user errors. But why do we see these spikes? So we need more data to understand why. And whenever we need more data, we generally go to logs. But logs really don't work as a starting point, as I previously mentioned. That is because imagine if you have thousands of microservices and each microservice produces hundreds of log lines. Going through these log lines is effectively tiresome, and you may or may not find the troubleshooting point. So in our virtual shop example, if you are lucky, you will be able to find the error, but it'll definitely take you a very long time. And as you saw, if this happens in your production environment, every minute of downtime will cost you thousands of dollars. So that's really not ideal. So let's take a pause here and see what are the things that are missing. The things that are missing are effectively correlation between metrics and logs, and between different microservices. And also, we need to figure out when and where exactly something is happening. That's where distributed tracing comes into picture. A trace essentially is a flow of requests through different microservices. If your application consists of thousands of microservices, that doesn't mean that a request will touch each one of them. At most, it will travel through a subset of those microservices. We at Epsagon believe that an observability solution should be able to help you throughout your engineering lifecycle, right from the design phase to the implementation phase to testing and production. So what do we need to do to implement observability which will help you throughout your engineering flywheel? Let's look at some of the examples. So with tracing, you should be able to visualize and understand your entire architecture. A tracing-based solution will be able to give you a holistic view of your entire application. You can use this to verify if something that you have designed has been implemented properly or not. On the other hand, you can also use this to do feature development. You can see how new microservices interact with the current ones and see if they're expected or not expected. You can also see where exactly the code is spending time. This will help you troubleshoot your performance and latency issues. So as you can see here, some of the microservices are consuming a lot of time, whereas some of them are not. And if this is an expected behavior, you're fine. But if this is not, then you can use the distributed tracing-based solution to troubleshoot this. As I mentioned before, correlation is very critical, and it was missing in traditional APMs. So with distributed tracing-based solution, you can actually connect metrics, logs, traces, and events together, and that helps you bring the entire context of what is happening within your system. Also, these days, a lot of users are facing alert fatigue. So it is very important to have contextual and configurable alerts. You should be able to configure alerts based on traces as well as other solutions. And then whenever you get an alert, you should know the importance level of the alert and also the context. The context is important because it helps you save a lot on troubleshooting time. As I mentioned before, a trace generally touches a subset of microservices. So this effectively helps to bring out focus on a particular subset of microservices and not other microservices that are not involved in that particular trace. So this way you will save tons of time in troubleshooting. Now with this correlation of metrics, logs, and traces, you have a huge ocean of data. And it is important for an observability solution to slice and dice this data in n number of ways that you want. So a couple of examples are shown here on the slide. So like in the first slide, in the top portion of the slide, you can see that there are total errors shown. And it is important to see 400 errors, but it is even more important to see 500 errors and why they're happening. So a distributed tracing-based solution will help you to do just that. And the similar story goes for an exception type. So you can filter down an exception type, whichever one is important for you, and then you can troubleshoot your application. So with all these things mentioned, you can add payload information to it. And that's exactly where you see what is happening between your microservices. As I had mentioned before, the mindset has shifted from the logic being within a microservice to between microservices. So it is very important to know what payload information has been transferred between microservices. And an observability solution which has payload information will help you to do just that. So let's revisit our old use case and see how distributed tracing based observability solution will help you troubleshoot your errors effectively. So as you might remember, the users complained about orders that were sent but not handled. So in a distributed tracing based solution, you focus on a few microservices that were involved, and you start, let's say, with a DynamoDB microservice. Here you can see that the key ID is missing. Which key ID though? Once you focus on the Kafka microservice, you can see that the username is empty. That's very interesting. But why is it empty? Once you focus on the auth01, you can see that the JSON token has expired. Now you know the exact reason, and you can use refresh tokens instead. So as you can see, within a couple of steps, you can clearly identify and troubleshoot errors with a distributed tracing based solution than going through tons of logs. So with this, we need to plan our observability journey very carefully. We need to identify what our business goals and architecture goals are. Then we need to select a solution, whether it's DIY, there are a lot of open source solutions out there, or managed. And then you need to implement that observability solution. That's where the pros and cons really weigh in. For a DIY solution, it might take a lot of developer effort, whereas for a managed solution, it will take much less effort. And then you also have to verify that your observability solution scales with your architecture. This is extremely important because containers and service functions can scale really fast within seconds. So your observability solution should be able to keep up with it. So I'd like to summarize this session just by saying that we went through how microservices have become the new normal and what challenges they have brought about in observability. We've also seen how to use distributed tracing in AWS environments and third-party services. And finally, we have seen how observability can be used to keep track of your architecture throughout your development cycle, as well as detect performance issues and reduce your mean time to resolution and detection. I'd like to conclude the session just by saying that a great observability solution helps you shift your mindset from being reactive to being proactive. So that's it for my session. Epsagon is giving out some giveaways, so you can go out and check out that link, and we can get the Q&A.
Awesome. Oh, you're giving out some stuff. We're giving out some stuff. Don't forget, everybody, we've got 50 mugs now. Giddy did retape his and put it together, even though we still lit and broke it and everything. So don't worry about that. All right, let's get to some of your questions that we have out there. I'm actually really curious about this one that somebody posted. How does Epsagon differentiate from Prometheus and other open source offerings?
Yeah, that's a great question. So in terms of Prometheus, Epsagon, you can actually send metrics from Prometheus to Epsagon. We've realized that Prometheus is a very powerful tool and a lot of companies use that. So essentially, we try to leverage the power of open source tools, and then you can effectively use the metrics to visualize your dashboards on Epsagon.
Interesting. I have another question here. These days, there are a lot of alerts coming through from various locations, various sources. How do you separate important alerts from other ones?
Yeah, another great question. So we support a lot of alerting mechanisms such as PagerDuty, Slack, Microsoft Teams, etc. And it is you can essentially set filters using traces and metrics to separate out all the alerts. And as I said, Epsagon essentially gives you the context for the alerts, so it helps in troubleshooting effectively.
Nice. Okay, so that is actually all the questions I have for Epsagon right now, though. If you have additional questions, please let us know. I'd like to bring Giddy on for the final raffle, not the final magic trick just yet. We're going to do the final raffle, and then I'll bring everybody back on for a quick recap, and then the final magic trick.